The materials, some of the things that you might like to know from a practical standpoint, you'll have 90-day online training access, free online training. You can start and stop at your own you're able to obtain that assistance. Over the course of the next several days, we're going to talk about Lean Six Sigma. We're going to go through the different approaches and different tools or strategies that are employed, because at the end of the day, what really it comes down to is this, that rather than relying on gut feel or intuition or best guess, we're going to capture and analyze data to make better decisions, more informed decisions. That's enable us to be more effective. It's going to cost us less money. We're going to have fewer mistakes. And the process that we're working on, or that element or piece of the business that we'll be working on, will be significantly better than it was before. And of course, that results in happier employees, a more profitable organization, or a more successful organization. And maybe most importantly, our customers will be happier with us as well. So by the end of the course, you should be able to talk about the basics of Six Sigma. So when somebody says, well, tell me about the course that you've taken, you'll be able to have a conversation with them and tell them all about what Six Sigma really means. And what it really means is this, that going back to about 1985-86 timeframe, a fellow by the name of Bill Smith, who worked for Motorola, he was a reliability engineer. He wanted to determine a better way to address the issues that were facing and really plaguing the organization or the business at that point in time. In fact, he wanted to get so good, so consistent with those processes within the business that they would effectively produce 0 defects. Or for every million defect opportunities, there would only be 3.4. Sigma is a statistical term meaning standard deviation. It's just a unit of variation, inconsistency, we might say, in a process. Well, at the Six Sigma level, meaning that there are 6 standard deviations or 6 sigmas on either side of the average of the process, all of that variation, all of that deviation is still so slight, so small, that it still fits within the customer's expectations. So that's very, very consistent and very, very good at meeting what your customers are expecting of you. That's really technically what the phrase Six Sigma refers to, and we'll go through that in more detail as we go through the course. Now, I mentioned the phrase DMAIC in passing, and DMAIC is really just an acronym. It stands for Define, Measure, Analyze, Improve, and Control. So over the course of the next several days, we'll describe all of the activities in the define phase. So at the beginning of a project, when we're determining what it is that we're going to be working on, who's going to be involved in the project, what the terms of the project are, in other words, maybe what resources do we believe we'll need for it, what are the goals or objectives, how much money, what are the benefits the organization or business should derive from that project. These are all the sorts of things that come from the define phase. It's really the foundation of the project. Once we've done that, then you'll be able to explain also what the measure phase is. And those tasks or strategies or tactics or whatever you want to use to define the work that we do. The measure phase is really that element of the project where we take stock of what we're working with, the process as it is today, for better or for worse, probably for worse, otherwise we wouldn't be working on it. But where are we at today? No fooling, no kidding ourselves. Let's take an objective, measured approach to figure out what it is that we really have to work with today. Once we've done that, we'll perform some data analysis and hypothesis testing in the analyze phase. That's where we start figuring out what are those elements or pieces of the process that are most responsible for its result. We'll also identify the possible improvement actions for the performed performance of variation in the improve phase. So in other words, once we've figured out those elements of the process that are most responsible for its performance, what are we going to do to fix those pieces that aren't working as effectively or working as well as they need to? We don't want to throw resources, time, money, energy, goodwill at things that aren't really important or aren't really responsible for a process. And quite often I've seen in organizations where people will sit around a room and they'll say, well, gosh, I've been doing this for a long time and I know this is the problem. Well, if you knew this is the problem, why is there still a problem in the first place? And so typically we'll be working on those projects where we haven't been successful in the past at figuring out why it isn't working as well as it needs to. And so in that instance, it becomes that much more important to put all of those preconceived ideas or notions aside and say, look, let's follow the data and see where it takes us. Because I can assure you, from my experience, and I've been involved in literally hundreds of projects over the years, that there are always some aha moments. And then finally, one of the things we'll need to do is define efficient operating levels for, you'll see a lot of acronyms through the course. And so what I'll try to do is I'll explain what they are. And at some point, just because it's maybe a mouthful, I'll revert back to using the acronym. So if I use an acronym and I'm not sure what it is, please just stop me and say, what is a KPIV? So when we look at defining the efficient operating levels for the key process input variables and the key process output variables in the control phase, what we're really saying is, look, we've taken a process that wasn't working very well today. We've figured out, we've taken stock of what it is that we're really working on, making sure that our measures are correct. Sometimes we're measuring the performance of a process and that measure isn't accurate. And so we're making decisions based on bad information. So we've made sure that the information we've got to measure the performance of the process can be trusted. We've torn it all apart to figure out the different pieces of it and which ones really matter and which ones maybe don't matter quite as much. And then we've identified through a variety of means, and we'll go through the different approaches or strategies throughout this course, to figure out what we're going to do about those. We've put them in place, we've tested them, we've determined they actually work, and the performance of the process is working better than it did before. We've been able to validate that through some statistical tests. The mean or the average or maybe the median in the process before is, was significantly worse than it is now, so we've made that improvement. But we have to put some mechanism in place to make sure that as the project team disbands and they go about their daily activities and go back to their regular jobs, we'll say, that the performance of the process doesn't deteriorate or doesn't revert back to how things used to be. This is the new way we do things. We need to make sure that those improvements stick, that they become habit, and so we put mechanisms in place to make sure that that is the case. Now, when I talk about KPIVs or key process input variables or KPOVs or key process output variables, think about it this way. If I were to write this as an equation, you could, if you have a pen and paper, you could actually write this down. Y is a function of X. That key process output variable, that dependent variable, the Y we'll say, that's the measure we typically use to evaluate the performance of a process, whether it be sales, margins, productivity, customer loyalty, whatever metric you use in your organization to evaluate the performance of a process, that's your key process output variable. It's your Y. It's a function of a bunch of things. So customer loyalty, for example, or customer satisfaction, it's a function of a bunch of things. Did you deliver on time? Were you nice to the customer? Did you understand what they really were looking for, so you delivered the right thing? Was it timely? All those sorts of things all come into play to create satisfaction or loyalty to an organization. There are probably a long list of things that could potentially impact customer satisfaction or customer loyalty, for example. They're the input variables, the key process input variables, and they're really what we're trying to figure out and understand their individual and their combined impact on the KPOV. In other words, sometimes individually those elements of a process will have an impact on the performance of the process, and maybe sometimes not so much, even though they're a part of it. And sometimes there's an interaction between those pieces of a process and their interaction or their impact on the output, the key process output variable. So that's something we need to understand as well. So that's the KPIV and the KPOV. And again, we'll go through this in more detail as we break it down. Now, anybody wanted to become certified through the ASQ, the material is aligned very nicely. So that's good. You know, I mentioned at the beginning, as I talked a little bit about my background, that I've worked with a number of different businesses over, you know, a number of different, across a number of different countries, and looked at a lot of different projects and a lot of different issues within those organizations. And so I think implicit in that explanation is that Six Sigma is really an industry-neutral discipline. You know, I know it says it can be applied to 70 different sectors, and I think that's probably to provide maybe an expanded version or explanation. I think you can, wherever you have an issue, apply Six Sigma if you need data to solve the problem because you don't already know the answers. So if you're working, whether it's in, you know, IT, manufacturing, healthcare, defense, and so on, whether it's in the public sector, the private sector, whether it's not-for-profit, wherever you've got challenges and you don't know the answer, if you do, then it's a just do it, of course. But if you don't know the answer, or there's enough at stake that you don't want to take the chance, then using data to make a more informed decision is probably a good idea. And in that respect, Six Sigma will be able to help you. Now, it's important to remember that the tools or the strategies that we'll talk about throughout this course, none of them were designed or developed or invented for Six Sigma. They were all designed or developed or invented to solve a specific problem. And so wherever you have that problem or issue within the organization, that tool will help you there as well. So in addition to doing projects where you'll go through that define, measure, analyze, improve, and control, or the DMAIC roadmap, you might also have problems or challenges within your business that you don't need to do a whole project, but you know that this tool that you learned through the course can help you solve that problem. And so keep that in mind as well. And so it's really an industry or business maybe neutral discipline. It can be applied wherever you've got challenges and you need data, either quantitative or qualitative data. Not always do we have or need to have numbers. Customer feedback, whether that's an internal customer or an external customer, that feedback, that information, that's data too. Now, it's a highly disciplined management tool with statistical, analytical, and data-driven approach. It focuses on developing a process, eliminating defects, and really ultimately delivering quality products and services consistently. So just as I said, where Six Sigma was developed at Motorola because they wanted to be so consistent that they were effectively always providing the customer what they wanted, that's what we mean by eliminating defects. The opportunity for defects has been eliminated or reduced as much as possible. Now, the Green Belt is the first step of the professional Six Sigma certification. And the Six Sigma Green Belt certified individual functions under the supervision of a Six Sigma Black Belt or perhaps even a Master Black Belt. After completing the certified Six Sigma Green Belt course, you should be able to use the basic statistical tools that we'll talk about in this course. And you should be able to complete a short run line of business, product line, business process, or service project. So something within your organization. Now, I will say that I've seen some green belts become really, really good and take on some really complex, challenging projects. And so as you practice using these tools within your organization, and you get better and more adept at using them, both for projects and just for other issues that you might come up with or have to deal with, that you'll become better and more comfortable, and it'll become second nature, where no longer will you be thinking about, gosh, this is a project or that isn't a project. You'll just be thinking about a challenge, and, well, now I've got this toolbox of strategies that are really problem-solving strategies. If this is my problem, then this tool or this collection of tools will enable me to solve that problem. So I guess that's really just a long-winded way of saying the more you practice using the tools, the better you'll become at using them. And even though the Greenbelt program is designed to help you with short-run line of business and so on projects, your ability to take on more and more complex challenges will be directly proportional to your comfort and ability to use the tools, and that, again, just comes with practice. Now, the target audience for the exam is designed for professionals who work in process improvement teams. So potentially, you might be leading that team or a member of that team. Solving problems related to quality, however you define that, and working closely with Six Sigma, Lean, and other quality improvement projects. Now, course prerequisite is to have 2 to 3 years of work experience in any niche or sector. I will say that, certainly somebody that is, fresh out of university, let's say, or fresh out of school even, that if you don't have 2 to 3 years experience, it can be harder because you may just not understand or have had the experience in an organization or in a business, and that in it by itself could be a challenge for you. Obviously, the more experience you have, it probably becomes a little bit easier to navigate through some of the challenges you have in leading a project. Because this is about changing the way from how we used to do things to how we're going to do things going forward. As a professional, you're going to be able to benefit from the Certified Six Sigma Green Belt program in a number of ways. So certainly you'll be able to demonstrate knowledge of the tools and the processes. You'll be able to assist with data collection and analysis for black belt projects, or projects that are more complex, perhaps, is another way to say that. You'll be able to lead green belt projects or teams. You'll solve problems with data and analytics, and you'll help in identifying the gaps in the process and fix them. Now, as a project leader, sometimes I see belts thinking that they need to be experts in that process. And I would say this, that no, you don't. Your job as a project leader is to be an expert in the tools and the methodology. But you can surround yourself with a team of subject matter experts. So I've certainly, over the years, gotten involved in projects where I didn't know a lot about that particular area of the business or the organization. But that wasn't my role on the team. It was to lead the project, to be an expert in the Six Sigma or Lean Six Sigma methodology. I was able to surround myself with subject matter experts, whether it was from IT or finance or human resources or operations or sales or from wherever within the organization. So I might have 6 to 8 people on my team, and they all represented a body of knowledge from a particular area that was critical to that process. This isn't a lone wolf activity, so when you surround yourself with a team of experts, you don't have to be an expert in everything. It's also a very, very good way to learn a lot because you're going to go through a crash course in that process. By the end of the project, you're going to become, if not an expert, certainly far more knowledgeable. So as a training opportunity, taking on projects across the organization is invaluable. You'll also get really very, very good leadership experience because you're leading a team of people to address a critical issue for the business that the business had not been able to solve before. And you're doing so in a way that delivers value to the business, and you're able to measure that value. So that's great exposure as well. Organizations are going to benefit from Lean Six Sigma in any number of different ways. Like identify the root causes of the problems, eliminate defects in the process, avoid process variation and waste. You'll standardize the process, address the key requirements, and gain a competitive advantage. Another way to say this is that the organization is going to become better at using data to make more informed decisions. They'll be able to solve their critical issues or problems or challenges more quickly at lesser cost. Or you can look at it this way, that employees will be empowered and more capable to address the issues that probably cause them headaches. I've never seen anybody go home at the end of the day and say, gosh, your organization from your competitors. Now there's 6 lessons in total in the course, and this is how it's going to be broken up. So we're going to talk about this morning, it's morning time where I am at least, an overview of Six Sigma and organizational goals. And so there are 3 topics that we'll cover. Six Sigma and organization goals, lean principles designed for Six Sigma. And then we'll get into the define phase. So we'll talk about project identification, the VOC or voice of the customer, project management basics, management and planning tools, business results for projects, team dynamics and performance. We'll move into the measure phase. We'll talk about process analysis and documentation, probability and statistics, statistical distributions, collecting and summarizing data, and measurement systems analysis. We'll get into the analyze phase, where we talk about both hypothesis testing and exploratory data analysis. We'll move into the improve phase. We talk about DOE, or design of experiments, root cause analysis, lean tools. And then finally the control phase, where we get into SPC, or statistical process control, and the charts that come from those. We'll talk a little bit about Schuhart, who came up with SPC this morning as well. And then finally, control plan and lean tools for process control. So that DMAIC roadmap is what we'll go through over the course of the next several days. We'll talk about the strategies or the tools, we call them in Six Sigma, that tend to be used in each phase. And we'll have quizzes at the end of each one. Now, the Certified Six Sigma Green Belt exam measures a comprehensive body of knowledge, as I mentioned before. Possible question types and lessons along with their details are as follows. So it's multiple question. There are 100 questions. As we talk about, questions per lesson, so overview of Six Sigma and organizational goals will be 13 questions. You get through the define, the analyze, the control, there are a number of questions from each section and so on. Now, it's an open book exam, so you're going to be allowed to refer to the training module, online sources, and tables as prescribed by the facilitator for that exam. Now, in the United States, the exam is conducted throughout the year. Details of locations and dates are available on the ASQ website if you want to be certified through the American Society of Quality. I think their website, asq.org/cert, C-E-R-T. And for locations other than the United States, it's conducted in 66 countries by international certification affiliates in June and December. And so my advice is always go to the ASQ website and just browse and take a look at it. Excellent information, and it'll also give you any details for those of you that might select to get certified through the ASQ. Now, the Simplilearn's Certified Six Sigma Green Belt examination can be taken anytime post-completion of the program that we're doing this week. And what it really does is it proves that certified professionals can analyze and solve problems related to quality, again, however you define quality, and can be involved in quality improvement projects. So when we talk about quality, think about it not from the perspective of the quality department, like quality assurance or quality control, but rather how effectively, how well are we performing a particular process for the business. Everything in a business is a process. Deming, who we'll talk about through this course, Deming's Edward Deming said one time, if you can't describe what you're doing as a process, you don't know what you're doing. What he meant by that is that the work we do in a business or in an organization is a series of steps. We do stuff. How we go about doing that stuff, the sequence we do those things, the people that are involved, how it all fits together, that's a process. And we'll examine how to build a process map later on. But I want you to think about, what does that process look like to the outside world? Not only to our coworkers, but ultimately to the end customer. That's really, think about how they receive it. That is probably a better way to think about quality. Is it consistently meeting their needs, and maybe even exceeding their needs? Now, for the exam, the duration is 4 hours. No prerequisite certificates are needed, but you do need to have taken the course. Now, some excellent websites for reference. I've mentioned ASQ.org previously, but that's one of them, of course. There's also i6sigma.com, there's sixsigma.com, there's sixsigmatutorial.com, which I was looking at just the other day, and it's very well done. Some useful books would be the Certified Six Sigma Green Belt Handbook, Applied Statistics for the Six Sigma Green Belt. But I would say that while those books are helpful, if you go to those websites, and Google is always good, Bing is always good, Yahoo is always good, so whatever search engine you happen to use, they're always helpful for finding stuff. So if you wanted to learn more about DOE or design experiments, or you wanted to learn a little bit more about Schuhart, who I mentioned a moment ago, he developed the statistical process control charts, SPC. You want to learn more about him, you can do that as well. Any questions from the material that we've just covered, this particular introductory module? No questions at all at this point? Okay.
Not at this point, thanks.
Okay. Presentation mode there. A little easier to see. Now, our first lesson we're going to talk about is the overview of Six Sigma and organizational goals. And I will say as we begin this that it's important to remember that we want to apply Six Sigma as a project to those issues that are critical to the organization. Not everything is going to be a project. If you know the answer, then just go apply it. However, I will provide a caveat, and it's this, that if there's enough risk or consequence to making a wrong decision, there's enough at stake that you need to be absolutely convinced and certain that you get it right, then that might be sufficient reason to launch a project. But if that isn't the case, you know the answer, then this isn't about applying bureaucracy or insisting that everything in the organization becomes a project, or that you can't make changes without a project first. If you know what to do, then just go do it. Projects are really designed to make sure that you get it right and that the work that gets done matches with the organization's goals. And so that's what we'll talk about through this lesson. So by the end of that, you should be able to describe Six Sigma and the organizational goals, explain lean principles in the organization, and explain design for Six Sigma. Or maybe an easier way to say design for Six Sigma is just DFSS. Again, I'll try to, once we see an acronym, I'll say it a couple of times in the long form, but again, it might be a mouthful, so I'll probably revert back to the acronym at some point. And if you forget what the acronym means, just stop and ask. We talked about it being a highly disciplined process that focuses on developing near-perfect products and services consistently. And at the Six Sigma level, we know that, as I mentioned earlier, that there are only going to be 3.4 defects per million defect opportunities. Now, that being said, I have worked on projects that did not get to Six Sigma yet were highly successful. You might not get to Six Sigma on your first project. You might be working on some issue within the business where when you evaluate through the measure phase and do that initial capability that we'll talk about later on, and you say, well, how capable are we today of meeting customer expectations, and you find out, gosh, that we're making a lot of mistakes, it's costing us a lot of money, that simply getting from, let's say, 1 or 2 sigma to 3 or 4 sigma might be $1 million, and that might be an awful lot of money to your organization. It is all about continuous improvement, and so that's going to lead to a focus on change empowerment, seamless training of resources, consistent top management support. And so even though we might end a project and start working on other projects, that doesn't mean that there aren't individuals within the business that are continually trying to improve from where we left off. And that might become part of the control plan. Now, I want you to think for a moment and put yourself in the following scenario. Let's pretend that you are the owner of a movie theater and that it requires long hours. You've been working hard at this for a long time. It's been quite a while since you had a vacation. But you also happen to be a member of the local Chamber of Commerce. And through that Chamber of Commerce, you happen to enter a draw where you were selected, and you've won a trip to New York. You've never been before. There's a convention going on in the movie theater industry, and you decide, you know what, I'm going to go to the convention since I've won a free trip and take a little bit of a vacation as well. And so while you're away, you call the manager that you've left in charge. You ask that individual a series of questions. Now, you're probably going to ask things like, what are the sales? Maybe what are the ticket sales? What are the concession sales? Any technical issues? Any employee issues? Those are the sorts of things that you're probably going to be asking. Now let's flip this around and look at it from the perspective of a customer. As a customer, you probably have a choice of other theaters to go to, number of theaters to go to. What are the sorts of things that you select or use to select the theater that you end up going to? Most of them play the same movies, so that may or may not be one of the things. But as a customer, I'll tell you that usually what I look for, I mean, there's the freshness of the popcorn and whether they put in lots of butter for you. How good is the sound system? How comfortable are the seats? Where I live, it's called a VIP theater where they've got these reclining seats and tables that come out, and they've got table service, and they'll bring you food. And if you want to have a hamburger and a beer, they'll bring that for you as well. So it's kind of stepped up service. It's a couple of extra dollars, but the extra service seems to make it worthwhile. It's always pretty busy, so they seem to be doing well. So as a customer, I'm looking for those sorts of things. Now you'll see a misalignment because as the business owner, I'm looking at certain things that I think are of value to me as an owner, but they don't seem necessarily to be aligned to what the customers are looking for. And so the whole idea for us is to say, well, gosh, if we had a better understanding of what it was that our customers wanted, then what the owner wants, those issues are probably going to fall into place. Now, if we think about that y is a function of x equation that I mentioned before, where y is the output, that's what the owner is looking for. Well, what are my concession sales? What are my ticket sales? What are my, do I have any technical issues? What are my employee issues? All those sorts of things. It's a function of other stuff. So ticket sales might be a function of the things that the customers are looking for. If I understand what those X's are, what those inputs, the key process input variables, or X's, I guess you could call them, the independent variables, all of those in combination, individually and in combination, they produce the Y. So if I can understand what it is that's driving ticket sales, and I can manage those elements and know which ones are most important, then my Y takes care of itself. The process that we're looking at is going to be, it's a series of design steps to produce a product or services required by the customer. That's true, but it's really just a combination and collection of the things that are part of our business that ultimately result in what we provide to our customer. And the better understanding we have about those elements or those things and their relative importance or their relative contribution to what the customer receives and their value to the customer, all of those elements, those pieces of the process, the more we understand it and them, the better we're able to deliver it in a consistent fashion. And so our project is really going to be around breaking down our process to understand the pieces and the relative importance of all of those elements, making sure that they perform in a certain way so that the customer at the end of it gets something better than they got at the beginning of the project. Now that might sound easy, at least it's relatively easy to say, but it takes a lot of work and it doesn't happen by chance. There's a discipline that takes place that has to be followed. It's a robust process because of the rigor that we introduce into the improvement process. So those inputs, something put into a process or expanded into operation to achieve an output or result. And you've probably heard of the 6 M's, the people, the material, the machine, the management. One is, well, Mother Nature, weather. So these are the things that might be part of the process. However you define the people involved, the staffing members, are they well trained? Do they have the right equipment to use? Have they been trained so that they're capable? All those sorts of things. And then, of course, the output is just the result. Now, we follow through the project the DMAIC cycle: define, measure, analyze, improve, and control. So in the defines piece, that's where we define the problem statement. We plan for improvement. The project team is formed. As I mentioned before, that's where we create the foundation for our project. And so we make sure that we know who's involved, what their goals are, objectives are. Here's where we think we are today. We don't have to validate that, but we think we're producing at this level today. If we get to that level, this is what it means for the organization. We think that these are the right people to be on the team. We think that it might cost this much money or this much time for this project to take place. I mean, it's all subject to change as the project progresses. But at the beginning or the outset, we lay that foundation on according to our best understanding at the time. During the measure phase, we're going to collect data from the process to determine the current quality or operational performance levels. This is sometimes the hardest part because this is where we have to be objective and realistic and not fall into a trap of fooling ourselves that we're better than we really are. So let's take stock of where we're actually at and then tear it all apart through the analyze phase so that to understand all of the elements. So we understand that we've created that y as a function of x equation. Now we start understanding the ordering of the x's, the impact that they have on the y, their relative importance or impact on the y, and so on. Because what we want to do is, rather than just throw a bunch of stuff at those x's, I guess we could call them, or those elements of the process, we want to be much more thoughtful about it, much more prudent. We need to do our due diligence so that whatever resources we invest in those pieces of the process, those x's, that they're well spent. We don't want to squander those resources because there's goodwill involved, there's probably money involved, there's time involved, and if we don't do it properly, then there's going to be consequences. People get discouraged, or there's money that's been spent needlessly that could have been better spent elsewhere. We've probably spent a bunch of time and so on. So it's important that we follow the roadmap because of that. And so as we develop the improvements and we test them, we move into the control phase. We want to make sure that we've validated that the improvements we've put in place work, that the process is performing better than it did before, that it's performing as well as we had hoped it would during the define phase, where we said we need to get from here to there. We probably put a statement that we want to improve customer loyalty as measured by, let's say, a Net Promoter Score, How likely would you recommend to a friend or colleague, the Net Promoter? Maybe we started out at 30 and we want to get to 55. And so we've put a bunch of things in place and we've tested it, and yep, we've got to 55. That's great. Well, we got to 55 because we are doing these things. These people are involved. These are their responsibilities as we've outlined through the improvement piece. We need to make sure that stays in place so that we maintain and sustain the control or the improvement. And so the control habits can die hard, it's less likely that things will go back to the way they used to because of that control plan. Without an effective control plan, yes, you might go through the DMAIC and be able to validate, gosh, we've improved from here to there, but as the project team disbands because you achieved your goal, if you don't have that effective control mechanism, people will revert back to doing things the way they used to. So the control mechanism is a really critical piece to that. Now, in each of the phases, there are going to be tools or strategies or improvement approaches that we use. None of these, as I mentioned before, were invented for Six Sigma. So as we talk about something like an FMEA created by the U.S. military, used heavily by NASA as an example. When we talk about statistical process control charts, they were developed at Hawthorne, Western Electric Hawthorne plant, fellow by the name of Walter Schuhart, who came up with those. We talk about Ishikawa or the fishbone diagram. These were developed to solve specific problems or challenges that they were facing. In Schuhart's case, and we'll talk about this in more detail as we go through those control charts, what he wanted to do was stop all of the machinists from tinkering with their equipment every time something seemed to go off a little bit. Sometimes it would be a little bit too much or a little bit short, whatever they were doing, and so they were always tinkering. And he said, look, there's always going to be random variation in the process. The key is to know when that variation is significant enough that it indicates some change in the process. Tinkering with something and trying to change it simply because there's that random variation, it's noise, it's not a good use of your time. Let's develop some charts so we know when it's unusual enough that it means that, yes, you need to look into this, otherwise you don't need to. That was his problem that he was trying to solve. So as we go through the define phase, some of the tools we might use, we've got the SIPOC, or Supplier Input Process Output Control, and we'll go through that in more detail. I'm just introducing the term at the moment. So that's what that acronym is. VOC, or Voice of the Customer. Critical to Quality Tree, Quality Function Deployment. This is going to be a mouthful. Failure Mode and Effects Analysis, or FMEA. Cause and Effects Matrix, and so on. So these are some of the tools you might use in the define phase. You go through the measure phase. You might do as part of your measurement systems analysis to validate that the data you're using to measure your process can be trusted. You might use a gauge R&R test, repeatability and reproducibility. You might use some run charts or control charts, which I've talked about, Schuhart developed. You might develop, well, you will develop some understanding of how capable your process is currently, both at the beginning of the project. You'll do this again at the end because you need to evaluate how well you're doing after the improvements have been put in place. So you'll say, well, gosh, how capable are we today of meeting our customer expectations? And you'll develop some indices for those, such as the CP or the CPK. We'll calculate those later on. And then DPMO, defects per million opportunities. You test for normality using the Anderson-Darling test, and so on. So these are some of the tools that you'll use as you go through the project. Now, I will say that, and as the slide says, and this is an important point, some of these tools can be interchangeably used between the phases. So you'll see the FMEA is listed here under a couple of different phases, and it's really just saying that, look, There may be times throughout the course of your project when this is the appropriate tool to use. It isn't restricted to just one phase. So using a Pareto chart in the analyze phase might be appropriate for you, but maybe it's also appropriate at some other point in the project. Using some type of a hypothesis test, maybe a t-test. Maybe that's something you'll use during the analyze phase, but gosh, you're also certainly going to use it in the improve or control phase because you want to test, as an example, the average or mean performance of the process before the improvements relative to after the improvements. You'll test those individual improvements before and after they were applied, and so on. So these are a collection of the tools. They're listed in the phase that they tend to be used most frequently or most commonly, but they can be used wherever you deem as the project leader them to be appropriate given whatever challenge you're facing. If you come up with a creative way to use one of these tools in a completely different phase and it makes sense to you, then by all means go ahead and use it. There's no rule that says you can't. There's nothing wrong with using a tool in a different phase if it makes sense to you. And I will say that I've seen belts take on basically the same project but maybe in different locations, and they went about solving those projects in different ways using different approaches or different tools, but they came ultimately to about the same conclusion and had both very, very positive, very good results and delivered a lot of value to the business. So there isn't always just one way to do things. Now, Six Sigma is going to be successful because of the following reasons. Management supports Six Sigma as a business strategy. If it doesn't, you've got a problem. This is all about changing the way we do things. And sometimes it can be intimidating for somebody that's been doing something for a long time that hasn't, that has a problem in the business and they haven't been able to figure it out, and someone comes along that's able to address it and effectively solve it. So they might be frightened by that a little bit. And so it's important to have management support of Six Sigma as a business strategy so that you say, look, this is no longer business as usual. We're now going to be putting more rigor into the way we solve our biggest challenges. We're going to make sure that we follow the data. We're going to use objective evidence to make important decisions as opposed to relying on intuition or gut feel or best guess. We use the DMAIC methodology for solving problems. We follow that define, measure, analyze, improve, and control approach. And as a project management approach, it makes a whole lot of sense. Let's define the problem, what we're working on, who's going to be involved, what resources, let's measure where we're at. Let's do some analysis on that information. Let's develop some improvements. Let's make sure we put in a control mechanism so that things are sustained. That should be almost logical and intuitive. It really is effective. It's a roadmap for Six Sigma, but I'd say as a project approach, it makes a lot of sense in and by itself. We'll have well-defined projects that directly impact the organization's bottom line, and we select those projects. If you can't talk about the money, you're going to have a difficult time getting people wanting to invest their resources in that project. There's a saying something to the effect of, you can talk all you want about it, but at the end of the day, it's always about the money. For most organizations, at least, that's going to be true. When you can present a business case and say, this is why it's of value to the organization when we do this project, because we're going to generate this much more revenue, we're going to reduce these costs either directly or even indirectly, then that's going to get people saying, the leadership of the organization saying, gosh, this makes a lot of sense, it's critical to our organization, there's a significant impact it's going to have on our bottom line, and so let's move forward with this project. It increases customer satisfaction and quality of a product or service. I would say that maybe instead of saying customer satisfaction, maybe even customer loyalty, so that they're going to continue to come back and maybe tell their friends to come back too. And it requires use of statistical methods. And we use the statistical methods when they're appropriate, which is certainly to figure out those X's and certainly towards the end of a project as well. We'll use them when they make sense. Now, some of the terms that we should familiarize ourselves with that will be used throughout the course are listed here. So when we talk about segment, I mentioned this at the outset, it's a standard deviation of a process metric, the average amount of variation about the mean for whatever we're looking at. So if we're taking a look at a process and we're taking some measure of it, today we probably take a measure of it tomorrow, we take a measure of it next week, and so on, we could calculate the standard deviation. Calculating these statistics manually when you could be doing more productive work. If you've got, whether it's Excel or Minitab or SPSS or some other type of software package that will do it for you, it'll do it in a matter of seconds, so why wouldn't you use that instead? And it'll get it right every time. An opportunity. So every chance for a process to deliver an output that's either right or wrong as per customer specifications. So if I expect that my Starbucks coffee is going to be hot enough for me, however I like it, hot or sweet or within a certain amount of time it's served to me, whatever I'm looking for as a customer, if it meets those expectations, it's right. If it doesn't, it's wrong. As a customer, I get to choose. It's not the business that tells me, I'm telling the business. So it's incumbent upon the business to ask me and understand what my specs are. It might be that they're using a metric that isn't aligned to what my expectations are. They think that they're delivering what I want, but they're not. A defect is every result of an opportunity that does not meet customer specs, does not fall within the upper specification limit or the lower specification limit, the USL or the LSL. So if I expect I'm going through McDonald's drive-through, and sometimes on some of them you'll see, you've been waiting in line so many minutes. If I expect to be able to, from the time I pull into the drive-through to the time I've paid and I'm driving away with my soda, that I should be in and out within 2 minutes, then my lower spec would be 0. My upper spec would be 2 minutes. Anything outside of, well, obviously you can't go below the lower spec, but anything longer than 2 minutes would be a defect. And the spec limits, limits set by customers representing the range of variation the customer can tolerate or expect. So a defect is anything that falls outside of those spec limits. Roll throughput yield, measure of a process efficiency expressed as percentage. Now, one of the things I found is that if you have a group of people in a process and, from the beginning to the end, and they're all in a room and you ask everybody who would be happy if each of you individually were 95% good. Everybody put up their hand and say, yeah, I'd be pretty happy. Frankly, a lot of people put up their hand when they're less than 95%, 90% even. Well, the problem is this, that individually the work you do, if you're 95% good, that means that 95% goes through to the next person. They're 95% good of your 95. Goes through the next person. They're 95% of the second person's 95. It's not 95 throughout the course of each event. It's 95 times 95 times 95 times however many steps are in the process. By the end of it, it's far less than 95. So when we talk about the roll throughput yield, it's important to remember that it's a percentage that individually, we may be pretty good at each individual step, but over the course of a multiple number of steps, it becomes much less. The end customer is much less happy, and as a business, if we don't understand that, we all think we're doing a pretty good job because we're all at 95%. That's not what the customer receives. So this might be an important number for you to use and think about in your project. And then defects per million opportunities, or DPMO, maybe is an easier way to say it. It's also known as a non-defect per million opportunity, NPMO, measure of process performance. Frankly, I generally see it stated as DPMO instead of NPMO. defects per million opportunities is more common nomenclature. Now, the Six Sigma quality means 3.4 defects in 1 million defect opportunities, as I mentioned. That means we're 99.99966% yield, or good. In a million opportunities, 99.99966% will be within customer spec. That's Six Sigma. That's pretty darn good. Five Sigma, you'd still be 99.9%. Sounds pretty good, but you'd have 233 defects. 4 Sigma, you're 99%, more than that. Still, most people are pretty happy with 99%. 6,200 defects. Now, the difference between 3.4 and 62, that's huge. There's some industries where, for every million defect opportunities, producing 6,200, that'd be catastrophic, and it simply would be unacceptable. We couldn't tolerate that. So it might sound really good when you say that roll throughput yield is 99 point, almost 4%, except that when you turn it and convert it to defect opportunities, it's a much larger number. Even 3 Sigma sounds pretty good at 93%. I'd be hard pressed to find an audience that wouldn't be pretty pleased with themselves if I told them you were more than 93% perfect. They'd be pretty excited. Wow, that's not bad. But for a million defect opportunities, there are almost 67,000. Think about the post office. Think about stock transactions. Think about the number of medical prescriptions issued each year. Is 3 Sigma good? Is 93% good enough? For that matter, is 4 Sigma good enough? 99 point, almost 4%. No, it's not. Now, if I'm talking about movie ticket sales or sound quality in a theater system, or driving through a McDonald's takeout, how much extra money do they need to invest to get from 3 Sigma to 4 Sigma? I'm not sure. Is it justified? Maybe not. Depends on your customers and the circumstances, of course. You have to do what makes sense for your business. Now, some of the organizational benefits of Six Sigma are going to be as follows. Eliminates the root cause of problems and defects in the process because you've identified what they are, and you've put effective control mechanisms in place through the control plan that will maintain those systems that prevent the problems from happening in the first place. Creates robust products and services. Fancy way of saying we give customers what they want and what they paid for. I think any organization, really, from an ethical standpoint, really, you have to give your customers what they paid for. It's wrong not to. So it creates robust products and services. Reduces process variation and waste. We've all gone to businesses where, maybe a restaurant, for example, where we went in and everything was great and we raved about it and said it was wonderful. Maybe we, told other people, and we brought some friends with us next time we went, and it wasn't very good. There was variation. That becomes problematic for a whole number of reasons. If your customers cannot trust you or count on you to be consistent. Sometimes my pizza is really good, and sometimes it's a little bit burnt. Sometimes it takes 25 minutes, and sometimes it takes over an hour. It's not going to take long before I stop buying pizza from that place. So it reduces process variation and waste. We're giving customers what they want consistently, and we're doing it in an effective and efficient way. Ensures customer satisfaction, generates profitable customer loyalty, I would say, provides process standardization. We enable our employees to know what they're supposed to do, when they're supposed to do it, how they're supposed to do it. We're setting them up for success. We're probably going to have lower turnover, lower stress, happier employees as a result. Reduces rework by getting it right the first time. Nobody likes to have to do something over again. It's not fun to do as an employee. It's certainly not very good for our customer, and it harms the business from a financial standpoint for both indirect and direct costs. Addresses the key business requirements, helps gain a competitive advantage, achieves the organization's goals. There are those organizations out there that we know and can trust because they always excel. They have a competitive advantage, and because of that can probably even charge a premium. And the kicker is that even though they can charge a premium because they're a little bit better than their competitors, maybe a lot better than their competitors, and they're consistently better, that they're also probably able to produce whatever product or service that they're offering for less money because they have fewer defects, fewer mistakes. So they get it on both sides. They get that benefit. So any number of benefits that can and what they ask for, what they value. The better able we are to do that, the more successful as an organization we're likely to be. It's hard to think of too many organizations that are successful when they fail to do that. Now, this didn't happen in a vacuum. It was more of an evolutionary process where, going back, and I mentioned Schuhart before, Dr. Schuhart worked at the Hawthorne plant, Western Electric, and developed statistical process control charts, SPC. You'll be pretty excited when you see them, and they should be used for every project. Sometimes you might think of it as start printing charts, but SPC, but it really just stands for statistical process control. So we might be looking at a process, however we measure that, whether it's we're measuring our customer satisfaction or customer loyalty, some productivity measure, maybe it's a profitability measure for a process over some period of time, and whether that's on a transactional basis. How long did it take to serve coffee to every customer on this day or this week or this month? What was our profit for this department each month over this period of time? We can track those in a control chart. We can see whether or not there's a lot of variability from period to period, transaction to transaction. And what's more, there's some tests that are done behind the scenes in most of the software that have SPC built in that will alert you to unusual circumstances. So, for example, if something is more than 3 standard deviations above or below the mean, there's a little flag that gets raised. You'll see a little asterisk or a box or some kind of notation that says, hey, this data point is unusual. And it's unusual for this reason. And what it really is signaling you is that, hey, I've got to go investigate. Something unusual happened in this instance, so I better go take a look. It'll alert you to trends or shifts in the process and so on. So SPC charts, they've been around a long time. This isn't brand new stuff, by the way. I mean, Schuhart was developed in the 1932, 1933 time frame. That's a long time ago. Quality circles came around in the 1960s. We had self-improvement groups composed of a small number of employees belonging to a single department. So even a Six Sigma team might be a small number of employees. They may or may not belong to a single department, however, but they've got that subject matter expertise. So it's kind of like a quality circle. But they've been around since the 60s. Most of you have heard of ISO. By the way, it's pronounced ISO, not ISO. International Organization for Standardization. It's really just a set of international standards in quality management and quality assurance for organizations to implement quality management systems. It's been around a long time, 30 years almost. I mentioned Bill Smith at Motorola. Now, Motorola went, and this is really how Six Sigma came to be. Malcolm Baldrige, who was the Secretary of Commerce under Reagan, was a proponent of quality and really believed that businesses ought to become better at their quality initiatives. And after his death, the Baldrige Award was named in his honor, and its inaugural recipient was Motorola. And when Motorola was asked, like, what did you do to create such a turnaround, a profound turnaround in your organization, your business, they talked about the Six Sigma thing that they were doing. And as a result of that, guys like Jack Welch at GE and Larry Bossidy and others started to pay attention and develop and implement systems within their organization, adopted Six Sigma as a methodology as well, and really it started to grow and blossom from there. So it's been around 30 years. So somebody that says, gosh, is Six Sigma a fad? I don't think so. I mean, as a methodology, Six Sigma's been around a long time. Lean's been around since, originally it was Toyota production system, it was back to the 1930s when it was really developed, I guess, and started to be used there. So the Lean Six Sigma methodology has been around a very long time. And even Six Sigma, the tools that we use have been around a long time as well. So they weren't developed for Six Sigma. It really just within this DMAIC framework started to use tools that already existed and were really best practices. Benchmarking, been around since 1988. I think there was some articles that really started to promote the idea of benchmarking, where an improvement process for an organization measures performance against best organizations in their field. So, I've certainly been involved in projects where you benchmark another department within the organization, maybe in a different location, or you said, look, we've got a supply chain challenge and this is our business. Obviously, one of our competitors will not allow us in to see what they're doing better than we are. But maybe there's another organization out there in a non-competitive field that really had the same challenge that we did fundamentally. And they figured it out and they've become very, very good at it. They're kind of a best in class. Maybe they'd allow us to come in and take a look and see what they're doing. And I've certainly been able to do that on a number of occasions. And most organizations, when you contact and say, we think you're best in class, and can we come in and maybe spend a day or two and just kind of shadow you and learn and see what you're doing, most are flattered, and as a matter of goodwill, they'll say yes. I'm hard-pressed to remember an instance where they said no. It isn't always convenient to come in the next week, but if you schedule something, most organizations will say yes, as long as they're non-competitive. Bell's scorecards, there was a Harvard Business Review that really started talking about that going back to the 1990s. I don't know of too many organizations today that don't have some type of balanced scorecard, even though they might use a different term. A collection of different measures that encompass different areas of the organization to provide a more holistic view. And then re-engineering, sometime in the mid to late 1990s, involves restructuring of an entire organization and its process. So designed for Six Sigma process, or project I should say, where we're taking a project on that is looking at a process that either doesn't exist or is too badly broken to be fixed, it needs to be redesigned or re-engineered, might be something that we would look at. And some of the quality gurus, as we've talked about. So Edwards Deming, as an example, came up with things like the 14 key principles for management, the 7 wastes, the Plan, Do, Study, Act, or PDSA cycle, and so on. Walter Schuhart with SBC, Joseph Duran, Kyoru Ishikawa, or fishbone diagram, is maybe how it's better known. The cause and effects diagram, but I know it better as the fishbone diagram. There's Taguchi. We'll talk about him when we get to design of experiments. And then Philip Crosby. So these are some of the quality gurus that we'll talk about. So the tools that we'll introduce and go through, they were developed by people within organizations that had specific problems to solve. And this is, these tools are what they came up with. And these are some of the individuals that developed those. Now, the most important part of the history of Six Sigma is Motorola initiating Six Sigma for process improvement, and then GE for using Six Sigma to improve the entire business system. So I talked about Bill Smith at Motorola. I mentioned briefly Jack Welch at GE. Now, if you go back to the early days of Six Sigma, organizations were a little bit more open with, I think, sharing some of the benefits they were receiving. So, Bill Smith, Mikkel Harry, they started it in 1986. I think they won the Malcolm Baldrige Award in 86 or 87, if I remember correctly. Jack Welch, sometime about a decade later, adopted it. They went on to, start receiving about $2 billion annually in bottom line benefits, Allied Signal, and so on. Today, it's used by literally thousands of organizations around the world. Virtually every Fortune 100 company uses it. The majority of Fortune 500 companies have programs. I've seen it used in both the public sector, the private sector, for-profit, not-for-profit. Governments are using it, and so on. I used to joke with my old boss that NASA was using it, so it must be rocket science. And their sales in terms of bottom line benefits coming from a Six Sigma program. Now, business system design is designed to implement a process or a set of processes because it ensures that process inputs are at the right place and the right time so that each step of the process has the required resources. So if we're looking at a business system and its design, it's going to collect and analyze data to ensure continuous improvement of its processes, products, and services. It includes the processes, sub-processes, or procedures, and steps as its subsets. So Six Sigma is going to improve the business system in a couple of ways. Firstly, it's going to continuously remove defects in the process. And secondly, it's going to sustain the changes. So we're going to take a look at the business system. We're going to figure out what's working well, what's not working well. We're going to address those things that are causing it not to work as effectively and as efficiently as it should or needs to by removing those defects and the opportunities for the defects. What's going wrong and why are those things going wrong? Let's put things in place to make sure that the process doesn't go wrong. People are set up to be successful and can be successful and are successful. And then we put things in to sustain those improvements. Projects are initiated to address present or future requirements in alignment with the organization's goals. Certainly we don't want to spend a lot of time and money and resources or energy tackling things that really aren't aligned to what is important to the business. Most organizations will have some type of a goal tree. In other words, they'll say, our goals for this period, this year, this whatever are, and they're typically, we want to be profitable over the cycle. We want to be first choice of customers. We want to be a great place to work. And maybe, we want to be a good community citizen. So most organizations seem to have some of those elements or variations of those elements. And they say that's really what we're working towards. We want to make sure that, if there's strategies employed by that organization to support those goals and, as you work down, to the initiatives and the tactics, you're going to say, well, in order for us to be profitable over the cycle, here's the specific work we need to do. We need to reduce costs in these areas, or we need to generate more revenue in these areas. Here's the stuff we're going to work on. We're not just guessing blindly at what we're working on. We should be working on the things that keep us up at night. That's kind of litmus test that I always recommend for organizations, that if it's an area of the business that's causing you enough stress or grief or money, it's what's keeping you up at night, then let's talk about that as being a potential project. So some of the requirements for a Six Sigma project are this: a group consisting of master black belts, champions, key executives will establish the criteria for project selection team assignments. So we've determined that we want to be the first choice of customers, and so we're going to start thinking about what are those potential projects we need to work on, and we're going to make sure we've got the right people involved. We're going to select a project team that has a skills or a mix of skills and expertise based on the nature of the project. We want to have the right people involved. The project should have a positive impact on profits. Now, I will say that I've seen some very effective projects that didn't have anything to do with profit, but that's certainly not the majority. The majority of projects certainly do, either directly or indirectly. But there might be times where an organization says, look, this is really important to our business for this reason or for these reasons. And because of that, we don't really know the answer, we're going to launch a project because it's that important, that we protect ourselves in this way. Maybe it's disaster recovery. So there might not be a direct profit motive for that project today at least, or one that you can measure, but maybe down the road it could have a serious impact on the business if you don't have disaster recovery plan in place. So you might do a project on that. But the vast majority, of course, will have profit attached because you need to have a business case. Improvements in a process should not adversely affect other processes. And typically what I'll suggest is in your process statement or your project statement where you say, we want to improve process A from here to there, I'll add a constraining statement as well. So our big why might be we want to improve first pass fill from 85% to 95%. In other words, first pass fill representing, do you have the product that the customer wants when they want it? Is it in stock, or do you have to back order it and ship it in and make the customer wait some period of time and incur some costs that you either incur yourself or pass along to them, which isn't a fun thing, or maybe the customer decides to go somewhere else because they don't want to wait. So first pass fill. The problem is that I can assure you that I can give you 100% first pass fill pretty easily. But the challenge is that you'll have to build a bunch of big warehouses and carry huge quantities of every conceivable project that a customer could possibly want. That's not an improvement that is going to fly with most organizations. So that's not something that most organizations would accept. Instead, I might have a constraining why, and it's this. It might have to do with inventory turns. So I want to improve first pass fill, but I don't want to adversely affect inventory turns, because otherwise we could get stuck with a whole bunch of excess inventory. Yes, we've helped make sure that we've got the right inventory customers want when they want it, but we've also got a bunch of stuff that they don't want because we didn't have 100% forecasting ability, so we just brought in a bunch of stuff. If instead we tie it to a constraining why, then you're helping the business overall. So that's what we mean when we say we want to improve a process, but it shouldn't adversely affect other processes. Now there are a total of 5 levels in the Six Sigma team. So you've got the top executives. They're going to lead the change and provide direction. They ultimately own the Six Sigma initiatives. So it might be the CEO, the VP of different areas of the business. They're going to be telling you, look, this is what's important for the organization. This is what we need to be focused on. And because they have a viewpoint or a vantage point probably that not everybody else has. They might have information that isn't widely known across the organization by everybody. So they are in a better position to be able to drive some of that decision making. You'll have Six Sigma champions. They'll identify and scope projects, develop strategy. They also identify and coach master black belts. So that might be a VP of quality, for example. It could be somebody that's actually called a Six Sigma champion. I've certainly worked with organizations that have them. You might, let's say, director or even director, executive director, I should say, of some area of the business, and you're a former master black belt, and you'll help be maybe the liaison or the conduit through which top executives will give their direction for the business, and that ultimately turns and is converted into project opportunities. You'll have master black belts. So they'll train and coach black belts, green belts, various functional leaders of the organization. Then they also take on high-level strategic projects, more complex issues, and so on. You've got black belts, so they'll apply strategies to specific projects and lead and direct teams to execute projects. And green belts, and they support black belt employees by working on the project and performing day-to-day jobs. In a lot of organizations I see and have worked with the difference between a green belt and a black belt is this: that a black belt typically will be a full-time Six Sigma person. That, you know, that's their job. That's what they do day in and day out. They work on Six Sigma projects. Whereas a green belt will be spending some portion of their time in, you know, their regular day full-time job, but they'll also spend a portion of their day working on a project. It might be within their realm or their area. So if they're a human resources person or a finance person or an operations person, then they would likely work on a project within that area as well. If you're an HR person, you might work on a project to reduce employee churn or to improve or reduce the time it takes to onboard new employees. Other than the financial one. And so as I mentioned before, we might say we want to be profitable over the cycle. You might also want to be the first choice of customers. So you might have a metric or multiple metrics around customer loyalty, customer satisfaction, or however you look at those aspects of being first choice of customer. You want to be a great place to work, and so you might have some measures or metrics that are centered around, you know, employee satisfaction and so on. The balanced scorecard translates the organizational strategy into actionable objectives and provides a framework for performance measurement. It's going to help clarify the organizational vision and mission. It's going to provide feedback on both business processes and outcomes. It's going to aid continuous improvement with respect to organizational goals. And it'll integrate the organizational strategy with key metrics from 4 major areas of performance. Their financial learning and growth, internal processes, customer. So financial objectives, tracking financial success, customer-facing objectives, intangible factors of success, learning from experience, operational goals for internal processes and performance. So if you've got a balanced scorecard for an organization, it's going to map the strategic objectives to specific metrics of performance in different areas of the business, perhaps from these 4 perspectives. So you'll have some number of metrics that provide that holistic view of how is the organization performing relative to the goals or the things that it believes are important to its continued and ongoing success. As we go about developing a balanced scorecard, we're going to be looking at interactions between perspectives or business units that are being considered to prevent uneven optimization. So for each perspective, the following are set. So we look at our strategic objectives. We've got measures that we want to achieve each objective. We've got targets for each measure, and we might have initiatives required to achieve each target. Again, we're going from that high level and drilling down to more specific and saying, if we want to be profitable over the cycle, that's important to us. Here's how we're going to be looking at profitability. Maybe it's according to division. Maybe it's a margin metric that we're using. Maybe it's some other financial metric or metrics that we're using, all the way down to, look, here are our targets. Here's where we are today. Where is the gap? And so if we've got a significant gap on this metric between where we are today and where we've set our target, then maybe we need to do a project on that area so that we can get up to what the target is. And so a couple of different approaches. We've got the 4-box model of the balanced scorecard, and we've also got the strategy map. So the 4-box model of a balanced scorecard is where we've got the KPIs, or the key performance indicators, being presented independent of each other. In this case, we've got financial, learning and growth, internal processes, and customer. And we've also got strategy maps. So we've got a chain of cause and effects relationships between the perspectives, which are represented by interlinked objectives in the strategy map. It's a one-page view of how the organization can create value. So we've got financial, customer, internal processes, learning and growth. And we're looking at from improving skills and knowledge, increasing process efficiency to lower cost. So we've got this strategy map looking at it. So again, just different ways to go about creating that, that balanced scorecard. Different organizations take different approaches. There are other approaches as well. Whatever makes sense for you and your organization, if it works, that's great. At the end of the day, you want to make sure that whatever your goals are for the business or the organization, and you need to have goals, by the way, you should come up with them, that you're making sure that the day-to-day work that we do is aligned to it. So there's a line of sight between the day-to-day tasks that we're performing and ultimately how that contributes to the overall goals and objectives of the organization. There needs to be that alignment. Otherwise, we might be busily working on the wrong stuff that isn't really that important. Now, I'm just looking at the time. I've got 10 minutes to the hour. I've been talking now for just shy of 2 hours. It might be, I'm not sure the time zone everybody is on, but why don't we take a 10-minute break? Is anybody opposed to taking a 10-minute break and meeting back on the hour?
Sounds good.
Okay, thank you very much. I don't hear anybody opposed to that, so that's great. I trust you all had a good break.
Yes, we did.
Good news. Certainly, as we continue to go forward, if anybody has any questions, please feel free to raise them. So on that note, let's resume where we left off. We're talking about the impact on the organization, not only of the balanced scorecard, but really how it ties into the Six Sigma initiative, or the Six Sigma program that we have for the business, and how it all ties together. So we've got the balanced scorecard and the strategy map, which is forcing managers to consider cause and effects relationships. So we want to lead to better identification of the drivers and really a well-rounded approach for strategic planning. Let's make sure that the work we're engaging in is impacting the organization in the way we want. And we're working on the right stuff. So the balanced scorecard is going to enable the organization to improve in the following ways. One, it can be easily communicated and facilitates understanding at all levels of the organization. That one-page document, let's say, that shows the goals, the strategies, the initiatives, the tactics, the metrics that we use, and any projects or any improvement work that we're doing, it all connects together. So it creates a clear line of sight between the work we do individually and how it impacts the organization at a macro level. So we feel part of the organization. And it's easy to communicate that without it being overly complex. It also forces an organization to manage information better so the quality of decision making is higher. It's a more thoughtful, more structured approach that, well, as the statement is, it forces the organization or people within the business to think about the work that we're doing and how it all ties together. By creating performance reports against a balanced scorecard, it allows us for a structured approach to report progress. So if this is what our balanced scorecard is, and this is how we're performing today relative to how we thought we should be performing, are we doing a good job, or are we struggling in certain areas? And if we are struggling in certain areas, what do we need to do about that? Enables an organization to communicate performance transparently and meaningfully. The overall objectives of the balanced scorecard can be cascaded into each business unit to enable that unit to work towards a common organizational goal. So what I've seen is some organizations that on a macro level will say, for the business as a whole, here are the goals, here are the strategies we've employed, here are the initiatives, tactics, and so on, our particular metrics that we use. But even on a divisional, departmental, on some smaller level, we're able to do the same thing. So we can say that, look, for the organization, these are the goals, but for our business unit or our division or our department, these are the strategies that we're putting in. These are the initiatives and the tactics and metrics that we're using. So this is how we plug into that piece as well. So I've seen that used as well. So it becomes even more searchable, I suppose, in terms of how that information can be presented and communicated across that particular. On a more local level as well. If it's a smaller, medium-sized business, that probably won't be as necessary, so they might just have one. So there's some variation there. Now let's introduce and talk about lean principles as we go through the overview of Six Sigma and organizational goals. Now I mentioned that Six Sigma came about, the phrase at least Six Sigma came about in the mid-1980s, or became popularized through Motorola's development of that in the mid-1980s. And then they won the Malcolm Baldrige Award. Lean principles came about, lean phrase at least, came about sometime around 1980s as well through a book that was written, Daniel Roos and James Womack and a few others that were writing about lean thinking. And it was based on the Toyota production system. And the Toyota production system really started going back to the 1920s and 30s when Toyota, which had been a textile company, started manufacturing trucks and really changed their business model. And so fellows like Ichiro Toyota and Taiichi Ono and others started to develop approaches or strategies to become better able to deliver what customers really value, to eliminate the waste or the non-productive work that was taking place. More commonly known as lean today, but it all derived from that early work at Toyota. So as we think about the lean concepts, lean is a continuous approach or process to eliminate or reduce the non-value-added activities and waste from a process. And what we mean by non-value-added activities or waste or end waste is any work that's done that doesn't change the process in some way that the customer doesn't value or doesn't ask for and isn't willing to pay for. All of that busy work. And there are 7 or 8 wastes depending on whose approach you go with, and we'll talk about those 7 wastes in a moment. And we can look at a process and go through doing something called a Gemba walk or a go and see. So rather than sitting in the boardroom, we actually go look and see the process firsthand. And we can identify those different wastes and say, gosh, does it really make sense to transport this material from here to there? Or why does this information need to have 5 approvals when maybe 1 or 2 would do, and so on. So it increases the continuous flow in the process and minimizes the stop flow and unbalanced production. And it can be particularly helpful when used before applying Six Sigma to a process. It helps you check the waste status of the process and eliminate or reduce waste and non-valued activities if they're present. So here we have an example of how lean might be applied before a Six Sigma project. We're going to look at an example here, and we're going to reduce some waste. So the problem is this. We have a welding technician that observes that sometimes he or she has to work with rusty components. And so a Six Sigma approach directly might be to reduce rusty components or reduce the rusty components. The traditional solution would be to use an oil coating followed by a cleaning process to prevent problems during welding. The lean solution might be first to identify how to reduce inventory to minimize waiting time for the steel components and ensure rusting doesn't occur in the first place. So you can see the difference in the approach. It's a different mindset. Lean focuses on the following 3 major issues in the process. So when we talk about non-value-added work, we've got the muda, the mura, and the muri. Really non-value-added work where the waste is muda, unevenness is the mura, and overburden is the muri. 3 issues in lean. And you'll notice a lot in lean that there are a number of Japanese words or phrases that are used. And so if you see muda used, for example, we're really just saying waste. Here, and I mentioned, and hopefully it wasn't confusing when I said 7, potentially 8 different types of waste. Traditionally, we used to talk about 7 wastes, but as you'll see on the next slide, there are a couple of other wastes that are also sometimes talked about. So depending on who you're listening to or who's telling the story about the wastes, you might hear some people say 7, other people say 8. So we have overproduction. That's a type of waste. So producing more than what's required. Customer needs 10 products and you deliver 12. You ever wonder why hot dogs come in batches of 12 but the buns come in packages of 10? Seems to be a miss there. Quite often an organization or a business, though, will provide something in a quantity that might not meet what customers really need. We have inventory, also referred to as stock, so test scripts waiting to be executed by the testing team. So wherever we have excess inventory, does it really make sense to have the quantity on hand that we have? Because you've got to, if you do, you've got to store it somewhere, and you've got to transport it, and you've got to probably insure it. Maybe you've got heating and lighting wherever it's stored as well. So you have all of these costs that accumulate and are caused by excess inventory. And let's not forget about excess and obsolescence as well. We've got defects, repairs, rejects. So any product or service deemed unusable by the customer or any effort to make it usable to the original customer or a new customer. An example might be errors found in the source code of a payroll module by the quality control team. That's one example. You can probably imagine for your organization the types of mistakes, defects, repairs, anything that is produced, a product or a service that doesn't meet the customer specifications. That's a defect. And those defects are waste. Motion, waste generated due to workplace ergonomics. So the finance and account teams sit on the first floor, but invoices to customers get printed on the ground floor, causing unnecessary personnel movement. I was working on a project one time where what we did was we created something called a spaghetti diagram, where you literally map out the workspace and then you draw a line every time somebody has to move to get something. And by the end of it is you track movement from, every time they need to print something, you've got to get up and walk to the printer, which is over there. You draw a line from where they are to the printer. Then you've got to go get something approved, draw a line from there to the approval person. They have to go get some office supplies. You draw a line. So it begins to look like a plate of spaghetti with these lines going all over the place. What we did was we actually were working with technicians in a repair facility. They repaired heavy equipment. Now, they were billing out at about $2 a minute, $120 an hour. So every time they stopped work to go get special equipment, to go talk to the floor person, to go get information from somebody, to go get parts, to go get supplies, to go to the computer station, it was costing $2 a minute. Now someone has to pay this. Either the business incurs it or you pass it along to the customer. That motion was a waste because they weren't actively working. They were stopped and you go get stuff. So as a result, it was costing money and time. And oh, by the way, one of the critical complaints of customers was it took too long to get equipment into the shop, which in turn cost them money because they weren't able to use their equipment to earn revenue for them, so they were constantly complaining. So this wasted time had all these costs associated with it. That's an example of motion, how costly it can be. Over-processing, additional processes on a product or service to remove an unnecessary attribute or feature. So a customer needs a bottle, and you deliver the bottle with extra plastic casing. Over-processing. Waiting. Parts are people waiting for the next process. So I was working with another, they were in agriculture, and when they would produce some quantity of, they'd have a Costco or a Safeway or Piggly Wiggly or some grocery store that ordered a bunch of cucumbers from them, for example. And they would have some order of, let's say, 1,000 boxes. Well, when the 1,000 boxes were up, they would move on from, let's say, a Safeway to a Costco. Well, they've got different boxes with different printing labels and so on. Once is Safeway, once is Costco. So they'd have to shut down the equipment. They'd have to change the settings to have the other box, which might be a different shape and size as dictated by their customer. Costco would say, you shall provide a box with these labels and this size and have this much stuff in it and so on. Safeway would say something different. So you'd have all these people standing around waiting, and they were frustrated because they said, you unscrew these 4 knobs, and invariably someone will drop one of the knobs, and it rolls under the machine. You've got to go look for it, and it was just a huge hassle. That was an example of waiting, and it was costing the organization a lot of money, and it was also causing a lot of frustration as well. So, that happens quite a lot in any business where people are waiting to do their work, and they can't proceed until something happens before that. You want to minimize that as much. Transport, unnecessary movement or unnecessary movement of the product in the process without adding value. So a product is finished, it travels 10 kilometers to a warehouse before it gets shipped to a customer. And certainly I've seen where you're bringing something in from the manufacturer and it's supposed to go on site, but for whatever reason it arrives early. Most people would think, well, that's a good thing, except that no, it isn't. Now we've got to transport it to a holding facility, and when the customer is ready for it, we'll ship it from that holding facility to the customer. That transport is a waste. Now I talked about the seven, they're the 7 wastes, and I think if I go back a slide, yeah, if you reorganize this a little bit, it would spell the acronym .WIMP. Maybe that's an acronym that you can, it's easier to remember. Someone says, well, what are the 7 wastes? You could do that one. Defects, overproduction, motion, or transportation, motion, and so on. Now the other 2 wastes are, 1 or 2 wastes would be underutilized skills, and this is typically referred to as the 8th waste, where you've got below optimum use of workforce capabilities, and not assigning the right people for the right task. When that's happening, that's obviously a waste. And then maybe underperforming processes, so automation of a poorly performing process, improving a process that should be eliminated, or asymmetry in process that should be eliminated. So different types of waste. And typically what I'll do with a project team is on a sheet of paper, I will list those different wastes. I usually use the 8 wastes. And I'll put them on a sheet of paper where, here's the process we observed, and here's maybe some suggestions what we do. Everybody gets a sheet. We go out and we walk the line and we see the process, whatever that happens to be, from start to finish. Whether it's in an operations, whether it's in a manufacturing facility, whether it's in an accounting office, wherever it happens to be, we'll try to go to the actual place it happens rather than theoretically talking about it. And everybody from their perspective will try to identify whether or not they see any of those wastes. And if so, then as a team, we'll try to brainstorm on some things that we could do to solve those wastes. I was working on something that was an environmental project where we're looking at ways to essentially become more green and to reduce greenhouse gas emissions and so on. And as we went through, I'll go back a slide, we were looking for, the environmental impact for each one of these wastes. And so if we had to transport something, well, was that using, was it a fuel-based, fuel-driven piece of equipment? Was it an electrical piece of equipment like a forklift that would then have to be charged overnight and so on? Did we have lights that had to be put on and heat that had to be supplied while things were being stored? If you make too much of something, how much energy goes into that? So it's just a different perspective. But again, they were all sources of waste. So you can look at it in a number of different ways, from different, through different lenses, and whatever makes sense for your particular project. You can, along with the team members, identify lots of opportunity to improve. And you get some quick hits typically as well, because you're probably starting to identify some things that cause frustration for the people that work in that process. And maybe they've stopped noticing it, or maybe nobody has listened to them in the past. So here's some examples of some of the different wastes. So if we're looking at inventory, materials are air freighted into a company for the materials requirement planning deadline on the first day of the month. Materials then sit in the warehouse for 3 weeks before they're used. Defect or reject, payment from the customer not received on time because the customer claims that the information on the bill of lading, invoice, and orders do not match. Over processing, the inspector rejects blemished parts that have been observed under a microscope when the spec allows for blemishes not visible from 3 feet away. Overproduction, by the time the work and process piles on the shelves and carts, reduce some assemblies done to a previous revision become unusable. So you can see some different examples of how there might be some wastes. So if you're thinking about your particular business, maybe the work that you even do or it gets done around you, it is a pretty helpful checklist, that .WIMP acronym. I've also seen with the 8 wastes downtime used. that you can go through that and think about all of the opportunities for improvement. And invariably, if you and team go through, particularly people that aren't used to that process, they don't live it, they're going to have a vantage point of someone that's going to question stuff that on the surface might get you scratching your head like, why would you ask such a silly question? But if you stop and think about it, it might challenge you to say, well, gosh, why is it that we do it that way? Maybe it really doesn't make a lot of sense. That we've always done it this way might not be the right answer. There are 5 steps in the process of lean implementation. First is to identify value. So, these are really the principles of lean. Identify value from the customer's perspective, not the business's. Too often, organizations will define and develop their processes, their policies, their systems, their way of doing things at their own convenience, rather than for the convenience of the customer. They think that customer satisfaction means being good to a customer rather than being good for a customer. This is about being good for a customer. What is it that your customers value? Do you even know that? Have you asked them? Have you sat down with them? Have you asked them those types of questions? Do you have a good enough relationship with your customers to really be able to understand what they value and what they need? Value stream mapping. So perform some value stream mapping. Map the process step by step from the very beginning to the very end and think about it through the lens of, does this add value or does it not add value? You can also look at some metrics associated with that particular step. We've already talked about the roll throughput yield. That might be one of them. That first pass yield for that step might be 95%, but what's the roll throughput yield at the end of the series of steps? And there are other metrics that we can look at as well. Maybe the time would be an important one. How much time does it take to perform this step? And what's the waiting time between this step and the next one? You want to create flow. So make value stream steps flow. You want to pull. So let the customer pull the products rather than push. In other words, if you build it, they will come. Well, they don't always come, and then you get stuck with all this excess and obsolete inventory. A great example of that would be, I remember I had a high school teacher who was telling us a story about, for his high school graduation, he was given a calculator. And his calculator at the time cost about $500, which, even going back to when he graduated from high school, that was a lot of money. But calculators were brand new at that time. I think he graduated sometime in the 1970s. So it was a big deal. That calculator did some really complex things, like it added and it subtracted and it divided and it did multiplication. And so this company that manufactured and had developed these calculators had built warehouses to stock a large supply of them because they figured the demand would always be there. And they charged exorbitant rates and they controlled the distribution and supply of them. The problem was a competitor came along and added the function of square root, which made all of their warehouses full of inventory obsolete. And of course their prices crashed and they ended up going out of business. If you build all of the inventory hoping customers will come along, they don't always. Things can change. Not only does it cost a lot of money to transport it there, to store it, the overproduction, all of those wastes that go into it cost you money and time and energy and a bunch of other stuff. But the consequence might also that's the foundation of all of this relentless pursuit of continuous improvement towards the ultimate goal of perfection, always trying to get better. So those are the 5 steps in the process of lean implementation. So to implement lean to a process, it's going to be necessary, firstly, and this should be self-evident, identify what the customer wants. So understand what the process should have to meet customer requirements. Value stream mapping, it's a visualization tool to map the path and identify all the activities involved in the product or service. So it's going to help identify and eliminate or reduce the non-value-added activities. So when you and the subject matter experts that are able to describe the process in detail, map it out. And I mean, I've seen some people, they'll use Visio, which is a Microsoft software program. I've seen people use Excel. I've seen people put it into PowerPoint. I've also seen people put yellow stickers on a side of a wall or a whiteboard. They map it out that way. Whatever works for you is fine. If it works, that's your goal. But you want to create this visual representation of the flow of products. How do all the steps fit together? What's the first step? What's the second step? And so on, all the way to the end. And you're going to look at each of those activities through one of three lenses. You're going to determine for each whether or not it's a value-added activity. So anyway, any activity that's value-added is going to be something that adds value to the process or changes the process for the better, and for which customers are willing to pay. So an example might be printing. So value-added activities, something you're going to look at, you're going to look at each step of the process and you're going to say, is this a value-added activity? Is it something that the customer is willing to pay for? A non-value-added activity is something which does not add value to the process through the lens of the customer, and for which the customers are not willing to pay. A delay in raw material procurement would be an example. Here's a controversial statement. A non-value-added activity might be inspection or testing, quality control testing. You say, well, that's necessary. No, it's not. If we did it right the first time and we did it right every time, we wouldn't need to test. The only reason we test and inspect is because we know we make mistakes. Customers should not have to pay for the fact that we make mistakes. It might be necessary, and it might be something that we understand we have to live with. It's still not something customers would want to pay for, typically. Now, that's the third piece, necessary but non-value added. Activities required for the process but which add no value to the customer's perceived value, a quality check. So something that might be important to the business, maybe the business has certain principles or certain legal requirements, something that they have to or believe they should follow, even though customers are not necessarily willing to pay for it. So for each step of the process, which of those three categories does it fall into? Certainly the value-added and the necessary but not value-added activities will stay, although you'll probably take a look at the necessary but non-value-added activities and challenge them to make sure they really are necessary, and you'll try to reduce the costs associated where it's appropriate to do so. But the non-value-added activities are those things that you want to remove. They're not necessary and the customers don't want them and aren't willing to pay for them. Why are you doing them? And they're often those activities that cause us the most headaches. They're usually those obstacles that get in our way and make us go home at the end of the day and say, gosh, I had a hard day. Now the lead concepts of flow, pull, and perfection are listed here on this slide. So flow would be, there should be a continuous flow of products or services through the business system. Any stop or reduction in flow is non-value-added activity and hence a waste. Pull, those products and services which are made as and when there is customer demand and not based on an estimated forecast. Again, this calls for you having a close relationship with your customer and understanding in pretty good detail what it is that they want and need, and of course the timing for those wants and needs. And perfection, and this refers to the complete elimination of muda or waste so that all activities are value added. Now, any organization can adopt either of the process depending on the requirements. So push, forecast demand, build stock, wait for customers to buy. An example might be a garment company that decides to manufacture 200 shirts based on past forecasts. The company makes 200 shirts and waits for the customer to place the order. That's an example of push. Pull, get customer demand, start production, deliver to the customer. The garment company receives an order for 200 shirts and then starts producing the shirts to deliver to the customer. I can't imagine going to a grocery store and saying, I'd like to order 3 apples and waiting for them to bring in 3 apples. So in some businesses, some organizations, it makes sense to have push. They just have to be very good at forecasting demand so that when I walk in, they've got a ready supply of fresh apples. Maybe apples are delivered, once a day or once every, whatever the period happens to be. So for some businesses, push and pull might make sense. If you're doing the wrong one, you're doing push because you've always done push and it makes more sense to do pull, then you need to figure out a way to become more pull-oriented. And as the bottom piece says, pull processes don't apply universally. This is an excellent example, but a pharmacy is more suited to a push approach. Now, in most processes, we're going to uncover some bottlenecks or some constraints. And there's something called the theory of constraints, where every process has limiting constraints or bottleneck. It's a tool to remove or improve that constraint. In other words, to remove it or to improve the flow of activities. So there's less of a weight or less waste. So the steps to apply the theory of constraints methodology are as follows. So we're going to identify the system's constraint. A constraint limits the process from achieving its goal. We're going to decide how to exploit the system's constraint, decide how to improve it so that it works to its full potential. We're going to subordinate the rest of the decisions of step 2. We're going to align the whole process to support the decision made in the previous step. We're going to elevate the system's constraint, so consider further actions to resolve the constraint, figure out what we need to do. And if a constraint has been resolved in step 4, return to step 1, repeat the steps to find the next constraint. So if we go through a bottleneck and we need to produce some number of units and we find that there's some piece of the process that is limiting us if we need to produce 200 units, and at one particular step we can only produce 25, where the next one maybe it's 100 and then 150 and then 200, in a 4-step process, it would be 4 steps. Then we would certainly go, firstly let's get the biggest bottleneck, that 25. Let's figure out what we need to do with it, resolve it, improve it as much as possible. Once we've done that, we go to the next one, and we work that way. So here, let's work through an example. So the question is, the 3 sub-processes in the packing process are coding or printing, filing, and sealing, filling and sealing. The data for the 3 sub-processes are observed and collected as a number of units produced in an hour. So coding, printing, 900 units per hour, filling, 720 units per hour, sealing, 780 units per hour. So how we want to implement the theory of constraint methodology. Filling is the system constraint because it's the smallest of the 3, 720 units per hour. We're going to assign repair and maintenance labor. We're going to carry out maintenance on the machine. We're going to remove the damages. Then we'll go back to step 1 and repeat the process, and this time we'll work on sealing. We'll take a look at sealing, figure out what's preventing it from producing more or us producing more, sealing more units per hour, and we'll implement those improvements and then go data units per hour before implementation, and then after. The sealing, unfortunately, doesn't look like we were very successful with, but we went to filling first at 720. We got it up to 840. That's certainly much better than it was before. We went to sealing. Looks like we weren't able to improve that, or the improvements would have cost more than the benefits derived. Maybe that was the case. Maybe we looked at it and said, gosh, we can get it from 780 to some larger number. However, the cost to do so is prohibitive. Wouldn't make sense from a financial standpoint to do that, so maybe we'll live with what we've got. or maybe 780 produces what customers need anyway. So again, whatever our decision-making rationale was. Any questions on the lean piece of it? We'll cover more on lean as we go through the materials, but before we move on to the next section, any questions on that topic? No questions? Okay. If any come up, even though we might be on a subsequent topic or a subsequent module, please feel free to go back and ask. So if we've, some point later this week even, you have a question about value stream maps or, 7 or 8 wastes, feel free to ask then as well. So we're going to go through topic 3, overview of Six Sigma and organizational goals. And topic 3 is design for Six Sigma. I'm going to start calling it DFSS pretty quickly because it's a lot easier than design for Six Sigma, which is a bit of a mouthful. Now, just as an opening statement, I will say this, that there are times that I have found that there was a need in the business to work on a project in a given area. And when we looked at the process, it either didn't currently exist, we had to develop something from scratch, or maybe it was a new service we wanted to provide that wasn't, to meet a need that wasn't being met, or the process that was in place was too badly broken to be fixed, and it made more sense just to say, look, this process is badly broken, we need to redesign a new one. Fixing it as is not going to get us over the goal line. So rather than spend a lot of time and energy trying to fix something that's broken, let's build something new that makes more sense. Maybe the circumstances have changed, and as a result, that process no longer made sense, and it was broken to begin with. So we designed something new. In those instances, design for Six Sigma and the methodology, the approach makes a lot of sense. So, we want to introduce a new product or service or a new category of product or service. We want to improve a product or service, again, maybe because it's badly broken, or we want to add to an existing product or service line. DFSS is an effective approach for us. Now, there are 2 major processes for DFSS. One is the IDOV, or the other is DMAIC, and they just represent, they're acronyms that represent different step process. So IDOV, identify, design, optimize, and verify. So we want to identify the customer needs to design the product or service. We want to design alternative concepts by identifying functional requirements, select the best fit, and predict Sigma capability. In other words, predict our ability to meet customer expectations and specifications. We want to optimize by calculating tolerance using a statistical approach. We want to verify the design by testing and validating and checking conformance to Six Sigma standards. The second approach is the DMAIC, or define, measure, analyze, design, and verify. So again, we're going to define customer requirements and goals for the process, product, or service. We're going to measure and match performance to customer requirements. We'll analyze and assess the design for the process, product, or service. We'll design and implement new processes, and we'll verify the results and maintain performance. So a couple of different approaches to taking on a design for Six Sigma project. Again, wherever we are trying to design or develop a new process, where one doesn't exist already, or where the existing process is no longer fixable or is just too badly broken, and it makes better sense for whatever circumstances we have to design a new one or develop a new one. And so as you can see, both of these really come down to this. Going out to your customers and figuring out what it is that they're looking for, what they need, what they want, and so on. Figuring out what you're going to do about it and building something that will ultimately be tested and vetted from and by your customer, so that you can say at the end of this, look, we've been able to understand what our customers are looking for. We've developed something according to their needs and wants, what they value, and here's the evidence of that, of them saying yes and acknowledging and affirming that, yes, you've successfully met our needs. They do differ in the following ways. So the IDOV be used to design a new product or service. A new process is designed. The design steps follow the identification of customer requirements. The DMAIC can be used to design either new or existing products or services. The existing process is redesigned. The design stage comes only after defining requirements and analyzing the existing product, service, or process. I've generally found that these are sometimes driven more by the feedback you get from your customer and from the expertise and the input from your team members. So your team members, based on your analysis of the feedback from your customers, will have probably a fairly strong opinion on which approach to follow. Now, one of the really effective tools that can be used is something called a quality function deployment, QFD for short. QFD is certainly easier to say than quality function deployment. It's also called a house of quality, and I'll show you why in a couple of slides. So either QFD or house of quality, HOQ, but house of quality is easy as well, refer to the same thing. It's a systematic process to understand customer needs and convert them to a set of design and manufacturing requirements. So it's going to help your organization to prioritize customer needs, which customer needs are most important. Not all needs are the same. Set targets to meet them. What are the strengths and weaknesses of the system and where should efforts be focused? So in the QFD, you're going to have to ask the customer relevant questions and tabulate their responses or the data, and identify the set of parameters critical to product design. What do your customers need, and what are the technical parameters that enable you to understand how to deliver and what to deliver to those customers? There's also an FMEA, or failure modes and effects analysis. I'm just going to start saying FMEA because that is a lot to say. And it's a preemptive tool that helps identify potential pitfalls at all levels of a business system. It's going to help identify the failure modes or the ways in which a product or service can fail and prioritize them, possible effects of the failure on the customers, and critical areas of the system. This is one of those tools I would suggest that virtually every product or project, I should say, should include. And it's also one of those tools that I would expect that you'll probably find a lot of use for outside of a project. Wherever you're looking at something and saying, gosh, before we put it into action or before we move forward with this, let's think things through from the perspective of what could potentially fail. If it fails, how bad would it be or how severe would it be? Do we have some understanding of how frequently that failure would occur? And how strong or how effective do we believe our control mechanism is? You can multiply on a scale of 1 to 10, how bad is it, severity, how frequently does it or do we think it will occur, the occurrence, times the detection, what's the strength of your detection mechanism. You multiply the severity times the occurrence times the detection, you get something called an RPN, or a risk priority number. I'll go through this in more detail in a few slides, and you can prioritize those. So certainly where you've designed a new system or a new process, it would be really helpful for you to say, look, before we go into production, let's think this through about the potential ways it could fail. Involves fabrication, assembly, transactions, or services. So in other words, where you're looking at a newer existing process and you're looking at potential ways it could fail, PFMEA is a very effective approach. The design FMEA used in the design of a new product to uncover potential failures, aimed at identifying failure modes, effects, and reducing them. It's done before the product is sent to manufacturing. All significant design deficiencies will be resolved at the end of the process. So we're going to assess the risks and help identify critical failure modes through that RPM. The higher the RPM, the higher the priority the product or process receives. In other words, high RPM is bad. And as I mentioned a moment ago, the RPN is calculated by the multiplication. It's the product of severity, occurrence, and detection, with each given a value in scale 1 to 10. So it's usually severity times occurrence times detection gives you your RPN. And the sheet will look like this. So for each step of the process, you'll say, what's the process step? What's the input? What's that X that you're looking at? How could it potentially fail? In what ways does the key input go wrong? Potentially. Not that you know for sure, that you're absolutely certain, potentially. Because at this point, it's either something that is theoretical, you haven't actually put into production, or you haven't collected data yet to validate what you think. So even though you might have subject matter experts on the team, and they're looking at an existing process or a broken process that isn't producing what you need it to, you're still guessing at this point. You haven't gone out and done any analysis. But it's a good filtering tool. So in what ways does the key input go wrong? What is the impact on the key output variable, customer requirements or internal requirements? What are the effects? How is it felt? Now, if it does fail, how severe would that effect be on the customer? Doesn't mean it has happened, doesn't mean it must happen. All it means is that potentially it could, and if it did, how bad would it be? Scale of 1 to 10. 1, would it be a low impact, hardly felt at all, or 10, would it be catastrophic in some way? Would it blow up, or would you lose the customer relationship and they go out and badmouth you or post songs on YouTube about how you broke their guitar? What would be the issue? How severe would it be? Potential causes. What causes the key input to go wrong? And this is where having subject matter experts on your team becomes so important. It's not just you as the project lead doing this. You and your team members are going through this, and having experienced, seasoned people that are subject matter experts have that insight that they can tell you pretty closely, for the most part, what causes the key input to go wrong. So if potentially this happens, what would be the root cause of that? And maybe you do some root cause analysis where you say, well, why did this happen? Well, why did that happen? So you dig down as much as you can to get to a root cause. You put in the occurrence. So how often does the cause or failure mode occur? Or do we believe it occurs? Something happens every time, a 10. Or just once in a blue moon, maybe a 1. And there are scales that you can use that will be more descriptive and more definitive of what a 10 is, what a 1 is, what a 5 is, and so on, for severity, occurrence, and detection. What's important is that the language or the wording in those scales, and some examples on a couple of slides, that the team understands and agrees that if this is a 5, this is what it means. You might not agree that it's a 5. Maybe someone says it's a 7, and someone says, no, it doesn't happen very often, or it's not that bad. Maybe it's only a 2. But you understand and agree that if it was a 2 or if it was a 7, this is what it would represent. So those scales are important. You put in whatever existing controls you've got. What are your current controls? Do you have any? Maybe you don't. I can assure you that I've gone through an awful lot of FMEAs where a lot of the potential ways something can fail had no controls. So you put none. Or maybe it's dependent on one individual and they use subjective judgment on it, or their subjective assessment on whether something meets the standard. Is that good enough? Maybe not. If the severity is really high and we believe it occurs with enough frequency that it's worrying, then probably not. And the detection. How well can you detect the cause or failure mode? If you can detect it and stop it from reaching the customer, then that's a good thing. If you can't, then that's a bad thing. And as a general rule of thumb, the closer a product or service gets to the customer, a failure gets to the customer, the more expensive it becomes. In the design phase, it's not terribly expensive. You can always redesign something. As it goes to production, it's getting more expensive. When it actually gets into the customer's hands, then it can become very expensive. They can sue you. There can be warranty costs. They can, again, tell people about you on social media. So the costs are, it's a bit of a wild card once it reaches the customer. It can become much more expensive. And then again, the severity times the occurrence times the detection gives you that risk priority number. So theoretically, if something was catastrophic and happened every time, and we had no ability to prevent it from reaching the customer, each would be given a 10. So we'd have 10 times 10 times 10, which would give us an RPN of 1,000. And I've certainly seen FMEAs that had RPNs of 1,000 Certainly they become issues that the project team goes out and investigates and collects data on to validate those numbers. And if they're validated, then that clearly becomes one of your critical X's that you need to address and resolve through your project. And here's a good example of a scale for severity. How critical the failure mode is to the customer or to the process. So a high severity rating indicates a mode, that the mode is critical to operational safety, perhaps. This is unlikely to be changed. So at the beginning of a project, you'll do this. You'll do it again at the end of the project because you want to validate that you've gone through this and you've addressed all of the issues that had high RPMs. So for example, if at the beginning of a process, you had an RPM of 1,000, at the end of it, frankly, the severity isn't going to change. If it fails, it's still just going to be as bad as it was before. The difference is, because of your project, what you've probably done is built safeguards in place to prevent the opportunity for failure from happening. So your occurrence will go down to 0 because or 1, non-existent is what I meant by 0, but your score will be 1. Your occurrence will be, non-existent because your detection mechanism is so good. It'll have a low score. So instead of 1,000, maybe it's only 10. Severity is still really high, so potentially if this failed, it would still be catastrophic, but thankfully you put such good safeguards in place that it can't fail anymore, so you don't have to worry about it. So unless you've learned something through your process that says, gosh, at the beginning of it we thought if this failed it was really bad, and what we've learned through the process is that, and the project is that it isn't so bad after all, then you could change it. That isn't usually the case. It's pretty rare for that to happen. Typically, if something's terrible at the beginning, it's terrible at the end. The difference is you've put things in place and it's not going to fail anymore. And so this is one example of a severity scale. If you and your team want to go in and reword these to make sense for your process or your business, by all means, this is not written in stone. Feel free to do so. I've seen variants of a severity scale, just like I've seen variants of the occurrence and detection scales, and it depends on who's presenting it, what type of business they're in, and so on. If you were doing this for a restaurant, it would probably look a lot different than one where you're manufacturing widgets. Here's an occurrence scale. Very high failure. Failure is almost inevitable due to this cause, and maybe give it a 9 or a 10. Greater than 1 and 2, 1 and 3. It's very defined in this instance. I really like this one because it is so well defined. But again, if you want to change this for some reason and it makes sense to do so, then by all means, you and your team will go in and change this so that you're all on the same page. Someone may think that something is repeated failures because they need to spend all their time on it. And so they say, gosh, I'm giving it an 8 or even maybe a very high, maybe even a 9 or a 10. But it seems to happen a lot. I'm spending 90% of my time. But someone else says, well, gosh, from your vantage point, I can understand that, but it really doesn't happen that much. It's just when it does, you always, because of your position, you always have to get involved. It really only happens maybe 1 in 400. So it should only get a 5. You both agree what a 5 is. You both agree what a 9 is. You just have a different take on what is happening in your case. You go out and you collect data and you validate, what the frequency actually is. And I've certainly seen seasoned managers that have been doing that job for a long time that seem to think something happened all the time. Detecting is impossible. The failure is given a rate of 10. At the beginning of a project, the failure mode is likely, for those issues you move forward with, going to be pretty high. By the end of it, it'll be very low because you've done your work. And so here we have an example where we've got cash withdrawal from an ATM, customer account debited but cash not paid. We have an extremely unhappy customer, so a 9. You can imagine going to the ATM and they take money out of your account, the balance is reduced, however, it doesn't dispense any cash for whatever reason. Maybe they ran out of cache and it didn't shut down. Maybe it was being serviced and didn't shut down. Maybe something else happened, but for whatever reason, you didn't get your money. I've had this happen to me once personally. It was quite a few years ago. It was pretty frustrating. I was in university at the time, so it meant something, the money I was taking out, and it was kind of a big deal to me. So you can imagine for customer severity would be pretty high. In this case, in the example, it's a 9. Potential causes: non-availability of cash in the ATM or network issue. The occurrence, team believes it happens, non-availability of cash in the ATM happens 7. So if we went back to our occurrence scale, we would see what that meant. The network issue, they gave it a 5. I think that was 1 out of every 400. Yeah, about 1 out of every 400 times. Current control design, set minimum limit warning is what they do today. They've got nothing in place for the network issue. So the detection scores, they gave a 2 because they think they've got something pretty good. I would question this and say, well, gosh, it's pretty bad, a 9. Severity that's a big deal. If you think it's happening 7, that seems to be a lot. Your detection score of 2, that seems like maybe you're being a little generous to yourself. I might have given it a higher score. Again, if something's bad and it happens as much as a 7, then your detection, in my opinion, wouldn't be very good. Giving it a 2 might be a little self-congratulatory. I would quite challenge the team if they came up with a 2 in this instance. If you're so good, why does it happen so much? But in any instance, 9 times 7 times 2 gives you an RPN of 112. With the network issue, happens 5 out of 7, so not as much, but you have you've got none. So for none, I would actually give that a 10 for none, not a 9, but in any event, you've got 4 or 5 in the example. I'm not sure what gets worse than none for current control design. So I say instead of a 9, I'd give it a 10. Excuse me. Now, initially what you can do is the team can say, look, some stuff might be just do it's. We've never really thought about it using this type of a tool before, and having to sit down and go through this process has caused us to think things a little differently, about things a little differently. And because of that, we have some insights. And here's what we think we can do. And maybe you've got an IT person on your team and said, gosh, I didn't know that was an issue, or I didn't know there was nothing in place for you like that. That's a fix I can take care of. So I'm going to go do this for you right now. So it might be a just do it, and you're all smiling. You just knocked off one of your X's. That's great. It doesn't often happen that way, but it's possible. It might also be that, gosh, there's really not much we can do. We can't really think of anything at the moment, or if we, what we think we have to do is going to cost us a lot of time or money, a lot of energy. Maybe we better validate this first. Let's go collect some data. Sally, Joe, you two are going to go collect data. You're going to collect this many data points in this way over this time period and get back to us in, I don't know, a week, 2 weeks, some period of time with what you find. Bring that back to the belt. The belt's going to do the analysis and present it at the next meeting. So recommended actions, that's where we can list all this kind of stuff. Responsibility and target completion date. Who's going to do it? When are they going to get it done? Now, that's about as far as you'll get in the initial use of your FMEA, because you're going to do it again. You're going to come back and revisit this at the end of your project. So let's pretend we've gone through and we vetted these, and some of them were critical, and some we thought were but really weren't, and some were just do-its. But in any event, towards the end of the project, when we've put our improvements in place, and we've validated those improvements are effective, in other words, they're having the intended impact on the process, we're going to come back and we're going to revisit this. And we're going to say, what action did we take? And let's rescore this. Now, admittedly, we're not going to go through the entire FMEA and address every issue on it, because every element of the process potentially will be listed here, and that's going to take forever and a day to go through and address and deal with all of them. We might have scored them, but we might calculate the RPM and prioritize those. And we might set a threshold and say, look, any RPN above this score we're going to address. Any below that score we're not going to address. And you might have different rationales for that. You might say, look, anything that has a severity of a 9 and an RPN, in other words, if it happens, it's really bad, and we think it's happening enough because the RPN ultimately is this, you might say we're going to address any issue over 300 or any issue over whatever number that happens to be. At the end of the project, again, you've addressed and dealt with those ones that you thought were important enough to spend time on. You come back and you rescore it. Now the severity, again, as we've said, is not likely to have changed. If it was really bad before, you've got a really unhappy customer, you still do today. The difference is that you've put things in place, maybe your IT put a control mechanism in place, so network issues immediately shut the thing down, so it's not, you might not be thrilled that you put your card in and you're not getting any money out, but or you put your card in, it's not working, but you're not going to have an issue where it takes your card and holds it, or that it takes money out of your account but doesn't dispense it. Those issues stop. So you just walk up and the machine says out of service, use the other machine. That's fine. Maybe it's just a longer lineup. But the issue's been addressed. It's still a 9 if it happened, but it's not going to happen. And your new occurrence, your new detection, your new RPN reflects that. Now this is a great opportunity as far as continuous improvement goes, because even though this project may ultimately be concluded, you've put control mechanism in place, you've got a control plan, you sign off, the sponsor of the project says, good job, everybody celebrates, they go back to doing regular work, the belt goes on maybe to another project. Whoever the process owner is, in other words, whoever manages this element of the business going forward, they have this repository of improvement opportunities, because not every issue in the FMEA was likely to have been addressed and resolved through the project. And so they can start looking at those one by one as time permits going forward. That's a very effective continuous improvement tool. Now, just coming up to, I know we're going to be taking lunch momentarily here. So for those of you that are really hungry, if you can hang on for just a minute or two. There's a quiz at the end of this section that it's a little hard with interactive online like this to do. So with the materials that you have, you'll be able to go through and take the quiz yourself. But think about, I'll ask and then I'll show you the answer. Which of the following is one of the perspectives in the balanced scorecard? Supplier, creditor, learning and growth, employees. Which of the following is one of the perspectives in the balanced scorecard material we covered? Supplier, creditors, learning and growth, employees. The answer was the 4 perspectives of the balanced scorecard are financial, customer, internal, business processes, and learning and growth. So C would be the correct answer. An opportunity that does not meet customer specs or specifications is called a defect, a non-specified object, an opportunity, or performance. The answer is A. Each unit has a number of opportunities as per customer requirements. If an opportunity does not meet customer specs, it's called a defect. QFD, or quality function deployment, which we'll cover later on, is a methodology, in more detail at least, is a methodology for removing bugs from a code, identifying and defining key customer requirements, measuring the reliability of a software product, training employees, and quality issues. The answer is B. QFD, also called voice of the customer, is used to identify customer requirements. For a process at 5 sigma level, how many opportunities have? Defects, overproduction, inventory motion are all examples of A, waste, B, 5S target areas, C, noise, D, value-added activities. The answer is A, waste. There are 4 of the 7, possibly 8 wastes mentioned in lean. Primary factor in the successful implementation of Six Sigma is to have A, necessary resources, the support of leadership of top management, explicit customer requirements, a comprehensive training program. The answer is B. Six Sigma requires change in the whole organization. Enhanced support of top management is essential. RPN is calculated by adding severity, occurrence, and detection, adding severity and occurrence, multiplying severity and occurrence, the product of severity, occurrence, and detection. The answer is D. Severity times occurrence times detection. Which of the following can be used to analyze, assess, and prioritize risk? QFD, BSC, FMEA, DFSS. Stands for Quality Function Deployment, Balanced Scorecard, Failure Modes and Effects Analysis, or Design for Six Sigma. The answer is C. Failure Modes and Effects Analysis, RPN, risk priority number, is the measure used to quantify or assess risk, analyze its cause and effects, and prioritize the risks associated with design or process. 9. Which of the following is a methodology to improve the process? DMAIC, DMADV, IDOV, or DFSS? A is DMAIC. That's the methodology for improving a process. DMADV and IDOV are DFSS methods meant for designing or redesigning processes. So in summary for this material, yes, they are typical questions for the exam. Great question. Thank you for asking that. So what we've learned in this lesson, Six Sigma follows the DMAIC process. It focuses on developing and delivering near-perfect products and services consistently. Again, as I mentioned before, and this is important, we have an ethical responsibility to give to our customers what they paid for. Taking a process to Six Sigma level ensures the quality of the product is maintained, with the primary goal being increased profits. I would elaborate on that in saying the primary goal for Six Sigma is to work on those projects that, while very commonly or usually lead to increased profits, really address any issue that is deemed to be critical for the business. When the H1N1 flu was really big a few years ago, I remember an organization that did a project on that. SARS was a big issue. I saw an organization do one on that. So another one that wanted to be a good community citizen and really believed that community involvement was important to them, and so they did projects with some nonprofits in the community. So again, you use it to address issues that are critical for the business. Lean is a continuous process to eliminate or reduce wastes and non-value-added activities from a process. And design for Six Sigma ensures that a new product or service meets customer requirements. And a process is at Six Sigma level using tools such as the Quality Function Deployment and the FMEA. Any questions before we break for lunch? I know that sounds like a loaded question. I have almost 10 minutes after the hour, so why don't we'll take 1 hour for lunch. We'll meet back at 10 after the next hour. I'm on Pacific time, so it's 10:08 for me. It would be 12:08 Central Time and 1:08 Eastern Time. Anybody opposed to taking 1 hour for lunch and seeing us, seeing each other back in an hour?
Sounds good.
Okay,
Sounds
that's great. And
Thanks.
if you think of any questions over the lunch time, feel free to ask when we come back.
Thank you.
You're welcome.